A Star Wars-inspired prosthetic, trends in AI, and the wave of digital transformation swooping the industry. All this and more in today's episode of Exploration into Technology.
Welcome to Exploration into Technology. This week in engineering,
a Star Wars-inspired prosthetic developed by engineers at the University of Utah is giving amputees the ability to feel. The robotic arm is being called Luke in honor of Luke Skywalker's artificial hand in The Empire Strikes Back. The device includes a prosthetic hand and fingers that are controlled by electrodes implanted in the muscles. The arm consists of metal motors and connectors with a clear silicone skin, which covers the hand pre-programmed to perform a variety of grip patterns. The entire device is powered by an external battery wired to a computer for processing signals. Thanks to the Luke arm, amputees can complete simple tasks such as picking up grapes without crushing them.
As artificial intelligence grows and expands to different markets, the trends of its domination will impact several tech verticals and future investments. By the end of 2020, the global artificial intelligence market is expected to grow 154% year on year, reaching a market value of $22.6 billion US. AI's penetration into different tech verticals is growing beyond the basic language of processing technologies like Siri and Alexa. Computer-aided design, machine vision, self-driving cars, and manufacturing equipment all have some level of AI and machine learning in their software. IBM is currently one of the largest owners of active machine learning AI patents. AI will optimize the way many industries operate, but many fear AI will replace human labor, particularly in automotive, assembly, and telecom sectors.
Metallic pipes have dominated the pressure piping market since their inception. Over the last 10 years, innovations in engineering have resulted in non-metallic NM pipes that can support higher pressures and temperatures. Unsurprisingly, companies are shifting toward non-corrosive, cost-effective, non-metallic materials in industries once dominated by metallic piping, including construction, manufacturing, and oil and gas. For engineers who are designing and working with these materials, expert guidance is needed, as the design requirements are significantly different from those applicable to metallic piping. This is why ASME recently published its non-metallic pressure piping system standards NM.1, NM.2, and NM.3. Developed by experts on the design, manufacturing, installation, and inspection of these systems, ASME's NM standards combine best practices and lessons learned to create a successful document. These new standards will help companies take advantage of the cost savings, time, and lifecycle benefits achievable through the use of non-metallic piping. For more information, please visit asme.org.
AI is not the only technology that is spurring digital transformation through industries in 2020. Industry 4.0 technologies such as IoT, big data, and machine learning were already transforming manufacturers' processes before the pandemic, but now the impact of the coronavirus has made digital transformations a high priority for most organizations. So, what does this mean for the industry? The rise of 5G, data analytics, AI, machine learning, and RPA, or robotic process of automation, were the top 10 digital transformation trends of 2020, as predicted by Forbes at the beginning of this year. The pandemic has accelerated the adoption of these technologies, and engineers have transitioned their design and manufacturing practices into the digital space. Processes such as computer-aided design, simulation, additive manufacturing, and the digital twin have created a new cradle-to-grave design to manufacturing timelines for engineers. Lockheed Martin, for example, designed and built the new OSIRIS-REx spacecraft utilizing the power of the digital twin. As reported in Mechanical Engineering magazine's October issue, researchers at Idaho National Laboratory have adapted digital engineering technology to help build the Department of Energy's proposed versatile test reactor. Other companies that have deployed digital engineering solutions have seen similar productivity gains. GE estimates use of digital engineering has saved the company more than $1.05 billion, and the U.S. Air Force is relying on this technology for designing and building its next generation of fighter aircraft. Tools that can enable working and collaboration at a distance are critically important now. Augmented reality and virtual reality are changing how engineers bridge the gap of the digital data world and the real hardware world. providing a level of collaboration not previously possible. Automation, manufacturing, and design companies have started to pay attention and have begun to explore the value of this disruptive technology. Makers of AR devices and software claim the technology to be fairly intuitive, especially for the next generation of engineers entering the field today. Analysts predicted it would take 3 to 5 years to complete digital transformation, but COVID-19 made it happen in less than a year. And the companies that succeed in 2020 will be the ones that are able to fast-track digital transformation.
What happens when additive manufacturing parts fail? A new virtual classroom course from ASME and Siemens Energy looks to explore just that. The course looks at failure modes of laser powdered bed fusion prints, covering the root cause and analysis of unique use cases, with a focus on avoiding future defects. This is part of a partnership between Siemens Energy and ASME to work towards scaling workforce development across the field of engineering. As a result, the engineering community will benefit from an expansive body of subject matter expertise rooted in more than 10 years of scalable serial production experience in additive manufacturing. All aspects of AM design, materials, and processes will be covered while connecting the AM ecosystem via Siemens to simplify collaboration, process, and streamline new production processes. Certificates of completion with 3.5 professional development hours will be issued to registrants who successfully attend and complete the course. The course is called AM Part Failure: What Went Wrong? And is available now. Find out more information at additive.asme.org.
EFES Careers 2020 kicked off on November 7th with several live sessions in career planning, job hunting, entrepreneurship, global careers, and even a CAD battle challenge. If you missed the live event, you can watch the recordings right now on the ASME EFES YouTube channel. You can also access exclusive interviews, webinars, and other relevant career development resources, along with details on ASME EFES Digital 2021 at efes.asme.org.
That's it for this episode. Thank you for watching. Please click that subscribe button and we'll see you next time.